Now we're continuing on page 5 of the Chapter 7 AP notes, and we're going to talk about quantum numbers. Quantum numbers are basically a code for electrons in orbitals. It's just a 4-number code for an electron. There are 4 quantum numbers that you can have. N is the principal quantum number. The principal quantum number tells you the energy level. L is the angular momentum quantum number. That tells you which sublevel. Is it an S, a P, a D, or an F? So you could see right here where S is 0, P is 1, D is 2, F is 3 for L. M sub L is called the magnetic quantum number, which is like which specific orbital is it? And M sub S is the spin, whether it's spinning up or down, plus or minus 1/2. So we'll take a few examples and we'll see what this means. Let's suppose we put an electron right here. Okay, an up electron in the first of the 2 p orbitals. So the first thing you want to know is what energy level is this for letter N? It's level 2. Now, what orbital is it in? It's in a p orbital. So p has a code of 1 for L. M sub L means which specific orbital is it? So if you look at the middle orbital as being a 0 with M sub L, you need to just count out positive and negatively. So 0 is the middle, and they just count out positive, count out negative. So this is going to be a -1 for M sub L. And lastly, the spin, it's spinning up, so it's got a +1/2 as opposed to a spin down, which would be a -1/2. So spin up is positive, spin down is negative. Okay, we'll try another one. Let's suppose that we do this electron right here, pointing down in a 3s. Technically, you could put the first electron pointing down. There's nothing magical about pointing up the first time. It's just that that's how we usually do it. But if you point it down, then this electron would have an n value of 3 because it's level 3. It's in an s orbital, so that means that the L value is 0. If we count the middle orbital for M sub L as 0, then we're done because that has to be the middle 0, which is a 0. And the spin is pointing down, so it's -1/2. Okay, let's take one over here. Let's take this electron pointing up in that orbital right there for a 4f. So we look at the energy level. The energy level is 4. The L value is which orbital is an F, so it has an F value of 3. The M sub L is which specific orbital in the set is it. So if the middle is 0, you go 1, 2, 3, and then -1, -2, -3. So this is a -2 M sub L. And the spin, because it's up, is going to be +1/2. So it's going to be +1/2. All right, we'll take our last one, 5D. Let's suppose that we point down in the last orbital right there. So energy level 5 is where we're at. L is which specific orbital? It's a D, so L is 2. The M sub L you have to count from the middle, so 1, 2, -1, -2. So this is going to be a +2. And the M sub S, it's spinning down, so it's a -1/2. So even though this looks kind of confusing, it's just a very, very simple coding for electrons. Now lastly, let's talk about what quantum numbers can go with which other quantum numbers. You'll notice that the energy level can tell you the values that L could be. So level 1 only has an S. S has an L value of 0, which means that L can never be the same as N, because level 1 only goes up to S. You don't have a 1p. So since you don't have a 1p, the L can never match the N. So this column of L always has to be less than N. All right, now let's go to the M sub L. You'll notice that for an S orbital, which only has one orbital, the M sub L is only 0. But for a p orbital up here, the L value is 1, and then this goes from -1 to +1, which is -L to +L. And let's look at the D orbitals. The L value is 2, and if you look at the Ds, the M sub L goes from -2 to 2. And lastly, the F orbital has an L of 3, and it goes from -3 to +3. So L can never be equal to n, and it only goes up to n minus 1. And the m sub L goes from -L to +L. -L to +L. That's the value range of m sub L. And then lastly, of course, the ms can go up to +1/2 or -1/2. So if we take a couple of really quick examples, if we did a set of quantum numbers that went something like this, if we did 3, 3, 2, +1/2, this would be wrong because L cannot match n. It has to be less than n. Okay? If we change this to a 1, then this would still be wrong because m sub L cannot be out of range of L from plus or minus. So those are the kinds of questions that you might see as well on the homework for quantum numbers.